I think I'm the first person in the world to fully do this. I want to recreate Super Mario Bros in Godot, and the first thing that came to mind was Nintendo's lawyers. How do I not get destroyed in court instantly and fined? I can't distribute Nintendo's assets, but if the user provides their own ROM, and my tool generates the assets from that, then I'm legally in a much better position. So the tool ships no graphics, just the instructions for building them. That became the main constraint everything else had to deal with. So before building any of this, I had to understand what I'm actually dealing with. The NES stores all of its graphics in a section of ROM called the CHR, Character ROM. These are 512 tiles total. The first 256 are for characters and enemies, and the second 256 are for backgrounds like bricks, pipes, and coins. Every visual in the game is assembled from combinations of these 8x8 pixel tiles. Each tile is 16 bytes. The encoding is 2 bits per pixel, means each pixel can be one of exactly 4 values, 0, 1, 2, or 3. Value 0 means transparent, and values 1 through 3 are palette slots that get filled in with real colors at runtime. And that's the thing. The tiles themselves don't have colors baked in. They have slots. When the game renders Mario, it says use palette 0 for these tiles, and palette 0 says slot 1 is red, slot 2 is brown, slot 3 is skin tone. When the same tiles are used for a different character, a different palette fills those same slots with different colors. The NES has 4 sprite palettes and 4 background palettes, and the full palettes the hardware can draw is from 64 colors total. So here's the problem. When you extract the CHR data, you get a raw grid of 8x8 tiles with no color, no labels. The tiles themselves have no names, nothing in the ROM says these 8 tiles are Mario walking. That knowledge lives entirely in the game code. My first instinct was to go straight from the ROM data to sprites, extract the CHR tiles, read the sprite lookup tables from a public assembly of Super Mario Bros, and assemble everything programmatically. I found Matthew Earle's Python script that extracts SMB levels using a 6502 CPU emulator. It actually runs the game code in an emulator to figure out where the tiles get placed where. It's a clever approach, but it only works for the background meta tiles, the 16 by 16 blocks that make up the levels, and it didn't handle sprite meta tiles very well. So I started down the path of reading the sprite data directly from the disassembly and assembling the tiles myself. And there's a flipping issue. The NES hardware can mirror any tile horizontally or vertically to save space. A Koopa shell, for example, uses the same tile on both sides of the sprite, but the right side is mirrored. To assemble a complete sprite, you need to know not just which tiles go where, but which ones are flipped and in which direction. So with all that, I can assemble a sprite sheet. And the first result was pretty good. The weird layout on Hammer Bros and Bowser's head is slightly detached. Let's fix that. I was working on this for a little while, and it was proving difficult for certain tiles and level creation, and I'm not going to pretend it was easy because I was starting to lose steam. Having to figure out which tiles are flipped and rebuilding them, it's almost like rebuilding the rendering engine, and that's a lot of work, especially when we recall how easy it is to download a sprite sheet from the internet. But I was determined. I had a different idea. For everything that remained, instead of trying to rebuild the assets from the CHR ROM, what if I took existing assets and mashed them back to the CHR? They are pre-ripped sprite sheets people made online, of course, and I used one of those privately as a reference. My tool compares each 8x8 cell in that sheet to every tile in the ROM, and checks the orientations. The output is a data file called a recipe. It's basically just numbers about which tiles compose which sprites. And the data is distributable because it's not artwork, it's just factual information. While this wasn't the sole approach I used, it majorly helped compose some of the complex assets like the title screen logo. And the auto matcher worked pretty well for most tiles, but some were ambiguous. Solid color blocks are a problem. So, of course, I built a web-based editor with React. The most important thing is, like, if I go to the clouds, you can see the composition of the clouds. And this is the bush variant. Pretty interesting. They're actually the same sprite, fun fact. Besides, I wanted to arrange them in a sprite sheet anyways. And now when everything looks right, I can export the whole thing as a data file. And yes, building this mapping by hand would have been completely insane. For the game engine, there's a bit of a problem with outputting the sprites as regular color images because some sprites need multiple color variations, like Mario Star Cycle or Fire Mario. So do I really want to try to export everyone as an image and then change them in the game engine? Well, check this out. Everything is indexed, and there's no real color stored. I know, it looks weird, but watch what happens when I apply the shader. So instead of having a bunch of separate sprites, I just have the one index sprite, and the shader handles everything, like star power, fire mode, underwater, it's all palette swaps. and that's closer to how the actual NES hardware works. This is the final animation that represents everything I've done so far.